right. Well, let's go ahead and get started. Today we'll go ahead and take a look at the exam 2 of spring 2015. So that just happened like semester ago. I would use that one as a preparation for our exam 2, which is going to be next Monday. So the exam is always 1 week after the practice, quote-unquote practice exam. So let's go ahead and get started with that. You can see that also it is in the array topic, even though array is going to be excluded in this class from exam 2 because we have not really gotten enough time to talk about arrays yet. But still, I want to have the exam because I want to get this done before Thanksgiving. Unless you guys prefer to have it right after Thanksgiving. With all the turkey and whatnot, you know, that may not be the best time, right? So let's take a look at it. The one that I have linked on in Moodle is called X2 Exam 2 of Spring 15. It's just a PDF. You guys can open it and look for it and actually view it. Most of those questions, in fact, all of the questions are in the form of I give you a chunk of code and you tell me what it does. And then for each student, the answer is slightly different because most if not all of these questions rely on your student ID as the input. Okay, so unless two people have identical student IDs, you know, the actual outcome is unlikely to be the same. They can be the same sometimes, depending on the nature of the code. So this is question number 1. So question number 1 is basically a program that goes from here all the way to here. If you guys need to have any more definite marking for the beginning and the end of a program, let me know, but right now I think the font here pretty much shows where the beginning is and where the end is. And the question is, assume the program is compiled and linked to an executable called main. What is the output of the program when the following is the command line? Did we talk about printf in this class? We did talk about printf, but not in the sense of printing a number. Did I talk about how to print a number in this class? I might have forgotten to do that. Okay, so anyway, with this line, it just prints an integer, which is, in this case, it is this part here. Okay. All right, so the most important part is we have a file called id.txt, and it contains your student ID, which is the 7-digit student ID. The question is, when I run this program, what is going to be the value of this expression? I cannot do that with a PDF. But the question is, what is the value of this particular expression here, which is ch1 minus 0x30 plus ch2 minus 0x30. Yep, go ahead.
Are you recording?
Yes, I am recording, and I can always double check. Here we go. Yep, so the recorder is on, but the volume is not up. That might have to do with my mic is, well, actually, since I'm using the microphone, you know, or the wireless microphone, it doesn't matter where I stand because it will still pick up, you know, here the same way. I guess I can bump it up a little bit more. There we go. All right, so what do you guys think? So for this particular program, you know, for testing purposes, we can just assume the student ID is 1, 2, 3, 4, 5, 6, 7. Okay. So the question is, the first question is, what is this line doing here? What is this scanf doing? It seems to be a particular kind of scanf that we haven't seen, but it's very similar to something that we have seen in the past. So what do you think this is going to do? Go ahead. It's trying to read 2 characters, okay? Because it has %C, so it's trying to read 2 characters. And where am I reading those characters into?
Character 1 and character 2.
ch1 and ch2, because you can see these are the second and the third parameters to the scanf function. So you are in fact correct, okay? This is trying to read 2 characters consecutive and reading one into ch1, reading the other one into ch2. Okay. All right. So let's go ahead and use Notepad or Mousepad to simulate the execution of this program. We can always GDB this one, but I think it's better to do it, you know, with notepad here. So the input file has 1, 2, 3, 4, 5, 6, 7, and a line feed character. Okay, so the line feed character, I just use LF to represent it. When it's trying to read in these characters, it's reading in 2 at a time. Okay, because you can see that in here, it's reading 2 characters. It's trying to read 2 characters at a time. But I only stay in the loop as long as the scanf function call returns a value of 2. In other words, if it's not returning a value of 2, I will get out of the loop. Okay, and it's also only in the loop that it will be doing doing the printing like this. So now the question is, what do you think this is going to do? Now you also have to remember to read this carefully. In fact, I did not read this carefully because right here it said, and nothing else, not even a line feed at the end. So the test input should not even have this line feed at the end here. All right, the first attempt, in the first iteration, which 2 characters will be read?
1 and 2.
The 1 and the 2, okay. So that means ch1 ends up to be the character 1, ch2 ends up to be the character 2 within the first iteration. What do you think scanf is going to return?
It's gonna print out 1 and 2.
No. Well, that's not the question yet. Okay, so you're a little bit ahead of me. What is scanf going to return when I ask to read 2 characters, and I did read 2 characters?
It's
What?
gonna return 2.
It's going to return 2. Go ahead.
The exit would be 1 because it's
No.
no.
It's going to return 2
Yeah.
because I asked about 2 things and it did read 2 things. So it returns the number of items that I successfully read, and in this case it would have read 2 characters, so it returns 2. Yep.
Okay, so when it does do a read and it's returning given the return value, if it's going higher than 1, is that only instances where you have several formatters, or would it go over if it's reading something that's more than 1 character long?
Could you repeat that question?
So when you use the scan function and it has a return value, and it's over 1, would that apply only in cases where you have separate formatters and each formatter has the condition met, or is it going to apply when there's-
Yeah, correct. Because it depends on how many items you are trying to read. So if I had 3, %C here, then it can return a -1 if it's in a file. It can return a 0 if there's nothing, which is really odd because when you try to read a character, you really cannot get a 0. You can have a 1 if there's only 1 character, and then we have end a file. You can return 2 if we have 2 characters, and then we have end a file, or you can return 3, which means we actually have 3 characters left in the file.
Okay, say you have a 3-digit integer and you read that, would it read it as 3 characters or just 1 integer entry?
You mean %D?
Yes.
Okay, if you have %D, it's a different story, because if you have %D, it will keep reading until the entire integer is read. So if you have 1, 2, 3, 4, 5, 6, 7, it will be 1 single integer.
So it only counts 1 for each discrete integer.
Correct.
Okay.
So when you try to read in integers, it will actually read as much as it possibly can, and it will still be counted as an integer. But when you try to read characters, then it's really just 1 by 1. Okay, very good questions. Yep.
I thought is scanf different than the other one that we were using? Is that I thought character was for like alphabet characters that were not integers.
Everything is a character.
Okay, but if you wanted to pass ABC, it would need to be %C versus.
It was still %C. There's an ASCII code for all the letters in the alphabet, and there are ASCII code for all the digits.
Well, I mean,
numbers.
when you did that simulation program in class, you specifically used. It's not scanf. What's the other one that we used? Printf.
We have only used scanf to read something.
Okay, so when you use scanf to make sure that if it read characters, that it would pass by those characters, and when you in that program you use C to filter between integers and characters in order to pass through the characters to get
No,
to more
we use
integers.
%C to clear away anything that are not digits.
Yes, so how, if C can also read integers, how did it know that it was reading characters and to pass by them if it doesn't have a discrepancy between reading integers and characters? Meaning, %C, I thought, could only read like A, B, C, any non-integers because...
No, that's not true.
Okay. Well,
I
then,
never said that.
Well, then how did you get the program to, if it did read non-integers, it would just pass by them?
Because everything is a character.
Right, but then how would it know one is an integer and one is a character if it just reads them?
It depends on what you're asking it to read.
Okay.
If you ask it to read a base 10 integer, then anything other than 0 to 9 will be considered non-integers, and it will say, okay, I cannot read this as an integer.
What was it in the program that allowed you to make that discrepancy? Huh?
Use %D.
Percent D is
That's
for
the
integers.
decimal.
So
You attempt
what was
to
the
read.
other one?
Okay.
If it wasn't percent D, what did you use?
We attempt to read it using %D first, which means, give me an integer if there is one.
Mm-hmm.
If there's no integer, which means it's not 0 to 9, it does not start with 0 to 9 or positive or negative symbol, then I move on and go like, because in that case Scanf would have returned a 0, meaning that there's something in the file, but it's not an integer.
Mm-hmm.
Then I use read Scanf %C to basically say, okay, let's just get rid of that character that is
Gotcha.
not an integer.
That makes sense. Thank you.
Mm-hmm. All right, so getting back to this one. Okay, so we have ch1 being the character of 1, we have ch2 being the character of 2. What do you think this particular expression is going to do? We are subtracting, yep, go ahead.
Two quick questions. So, is the int there a typecast there?
Yeah, the int there is a typecast.
And
It is usually not needed, but I'm just putting it there anyway to be sure.
And in this case, would it apply to the full expression or just the first set of parentheses?
Well, that's a very good question too. Okay, this boils down to what operators will do. Okay, so let's see. So we'll go ahead and evaluate this using the parentheses. They would indicate the ordering of evaluation. So we have to evaluate. Let's say this one first. Okay, the result of this one, okay, is actually an integer already. So the cast of to integer is not really needed. What? How can this be an integer and not a character? Because ch1 is clearly of char type. What about the other guy? What about 30 with a 0x in front of it? What is the type of that? Okay, first of all, what is it? It starts with an H, hexadecimal number. And every hexadecimal every number has an innate type of what? 123, okay, 1, 2, 3 is a integer, but what is the type of that integer? It's an int, okay? It is an int, okay? Every number is an int, okay? So 30 as a hexadecimal number is an int already. So what the compiler would do is to say, hey, you give me something of mixed type here, because the left-hand side is a char, the right-hand side is an int, and you want me to do some kind of operation with these two. So what do you think the compiler is going to say? I cannot do this. Okay, you got to make sure that the programmer has to make sure both sides have exactly the same type. Or do you think the compiler would do one of the things that we talked about a long time ago? What is that?
Okay, terminology wrong.
Coercion, right? Okay, what does coercion do?
It implicitly casts the left-hand side to match the type of the right.
Yep, it can automatically make it longer. So a char is only 1 byte. That's okay, because anything you can represent using only 1 byte, you can also represent using 32 bits. Okay, so that's what the compiler is going to do, is to say, well, since the right-hand side is 32-bit, but the left-hand side is only 8-bit, I am going to change the type of the 8-bit one into 32-bit first. But that's not going to lose anything, because anything that can be represented in 8 bits can also be represented in 32-bit. So now the real question is, what is the value stored in ch1? And let's flip back to the test case here. So we have ch1 having the character of 1, but what exactly is that as a bit pattern? Yep.
So that's going to be the ASCII code for 1, which
The ASCII code of the digit 1, exactly. And do you remember what is the ASCII code of digit 1?
No, but I cheated and it's 49.
Yes, 49 in decimal, which means it is how many in hexadecimal? Hexadecimal is base 16, so how many 16s do we have in 49? 3 with a remainder of 1. So 3-1 is the hexadecimal representation of the digit 1. So we are subtracting 3-0 from 3-1 in hexadecimal. And what do we get? Just 1. And then the other one is 2. Okay, so 1 plus 2 is 3. So the first printf is going to print a value of 3 because it's just adding up the value, the integer value of 1 and the integer value of 2. The next one, it will be 3 plus 4, which is 7, and then it will be 5 plus 6, which is 11, and then it's going to stop because this is the last character. There's no line feed after the 7, which means the last scanf will return a value of 1 because it's asking to read 2 characters, but there's only 1 available. And as a result, scanf returns a value of 1, 1 equals 2 is false, and then we get out of the loop. Yep.
I'm sorry for asking this, but what's a line feed?
What is a what?
Line feed?
Line feed is what you use to mark the end of a line. Yep. So when you look at the hex dump of a file, every time you break a line in a text file, there's a line feed character, which is ASCII 10. Yep.
Are you also subtracting this a hexadecimal representation of 0 as well? ch1 minus 0x30?
That turns out to be the hexadecimal, that turns out to be the ASCII code of 0, yes.
So you are subtracting by 0 as well. The minus 0.
It is subtracting the ASCII code of 0 as a character.
So is it not subtracting 0? I'm not understanding.
Okay, when you say 0, there are...
The hexadecimal representation of 0.
We are subtracting the ASCII code of 0, which is 30 in hexadecimal, or 48.
The way the ASCII code is laid out, if we subtract 0 from it, it leaves the remainder that turns out to be the ASCII code for the number.
So that makes it so that we can...
So that means, with this example, it means, it might be helpful to bring along an ASCII code table with you, okay? Because, remember, in the test, it is open book, open notes. Anything that is either printed or handwritten prior to the test, you can bring it in, okay? But no sharing, though. Yep.
Can you repeat all of the int?
Say?
The one you put in bracket, all of the print int something, char1.
That just prints the integer value. I think we did not talk about the printf.
No, that is when you said with the ASCII code. Yeah, that
You mean this part here?
Yeah, I didn't get it when you said because the char1 is going to return 1 and then minus that's the hexadecimal. I didn't get it.
Okay, what is ch1?
That's just 1.
No. What is 1? Which one are you talking about? Okay, when we say 1, it is very confusing because when you say 1, you can mean the numeric value of 1, you can mean the ASCII code of the digit 1, or it can simply mean ONE1. Which one is it?
The ASCII code.
The ASCII code of 1 is correct. Okay, so what is the ASCII code of 1?
You said 49.
49. Yep, 49 is a decimal number, right?
Mm-hmm.
And what is 30 in hexadecimal? 0x30.
0.
No, it's not 0. It has a value. What is the value of hexadecimal 30? 48 in decimal. So we are subtracting 48 from 49, which is 1. Is that okay?
Yeah.
Okay. Yep, go ahead.
So what about on the second one? The second character is 2.
Yeah.
So you're subtracting 1. What's the hexadecimal representation for 2?
For the digit 2,
Uh-huh.
it's 1 more than the ASCII code of 1.
50, and so minusing the hexadecimal, it's going to leave it as 2.
Correct. So this evaluates to a value of 1. This evaluates to a value of 2. 1 plus 2 is 3.
What would it be if it wasn't 1 and 2 in the ID? Could you give another example of different
Then it will be
digits?
whatever it is, right? I mean, you just have to look up the ASCII code to find out what it is and then subtract 48 from it. Okay? I'm not going to go over all the possible cases because there are lots of possible cases. Yeah. Okay. Any other questions about this one? I think the focus is not what is the actual answer. Okay, the actual answer is important, but what is more important is what is going on when we evaluate expressions like these. Okay, that is the most important part. Okay, one important part is what does that mean in Scanf? Okay, it's trying to read 2 characters at a time. What does Scanf return? It returns the number of items that was successfully read. Okay, if there's anything read. It can return 0 if there's nothing it can read but the file is not empty. It returns a -1 if you have an empty file or you are at end of file. And then over here we have a subtraction, which doesn't seem very difficult, but we have to look at the types of the 2 sides. This is a char and this is an integer, and in the case where the types do not match, the compiler, whenever possible, would do coercion to bring the 2 types up to the same type. Then you can do the subtraction. Okay? Yep.
Can you go over the printf and just after?
The printf is the reverse of scanf. You know, we did not talk about this, so I will have to change the type of questions in this test. Basically, this is printing in decimal in base 10 signed. What is the value of the expression after that? So it will basically look at the value of this expression and then print it out in base 10.
So the \n.
The \n is the line feed character. This is how we specify it. You know,
So
give me a
it's just putting it on the line back.
right. Yeah. So it will print a number, and then it will break open another line and then print another number. Yep. In fact, this program is compilable. I mean, you guys can actually run it if you want to kind of see what it does. Go through GDB, you know, if you want to find out exactly, you know, in what step it's going to do what. Okay. I will adjust the questions accordingly for this class because we covered the material slightly differently compared to last semester. Now this one has a lot of printfs, so instead of asking you about the printfs, I will probably just ask you, okay, what are the values of x and y instead of printing, x and y, and what is the value of r, at those specific places. This one is a little bit longer, okay, so we'll go ahead and answer these questions. The first question is f recursive, okay, and obviously the answer is either yes or no. If someone answers a maybe, then it will count it as neither yes nor no. Because I can imagine someone can say, well, I don't know, maybe. Hoping that maybe will count half as yes and half as no, so I will get both answers covered. Okay, is it recursive? Is f as a function recursive? What makes a function recursive? It calls itself. Okay, so does f call itself?
On the true or false on line 3.
Yep. There is a potential that it might call itself that makes it recursive. Okay, so f is in fact recursive. So what I want you to do here, okay, since in the previous semester I did talk about printf first, is to write out the actual output of the program. So instead of doing that, I will ask you to say, okay, on certain lines, okay, tell me what are the values of the variables. And at this point, since I did not, change the question, so we'll go ahead and I'll just explain this part here. So I'll explain what is this statement doing, okay? What do you think this statement is doing? For those of you who kind of get a grasp of the printf already at this point. Yep.
It says x equals, then it returns whatever value is stored, but it returns integer value of x.
The value of x at the time when printf is called. You're absolutely correct. Okay. So this is the reverse of scanf. Anything that is not starting with a % is going to be printed verbatim, just like with your program. Your very first program, what was it? your world rocks, right? Okay, and whatever you put into the double quotes is whatever is printed. So the only part that is special is actually the %d. But %d, all it does is to substitute, is a placeholder. It's basically saying this is a placeholder. The actual value or the actual thing to be printed would be the decimal value, or it will be the value of the expression that follows, but in base 10. So it will print the value of x in base 10. Is that okay? Yep.
So if x ended up being a letter value, would it print the ASCII code in decimal?
No, because it always prints an integer.
Okay.
If
So
you
it
want to
would
print
have
a
an
character,
error.
then you have to use %c.
Okay, so it would have an error if it was a letter.
No, it won't, because it will print the ASCII code of the letter instead.
Okay, that's what I thought.
Yep. Go ahead.
To make sure, so that will print x equal, and then you'll go to the next line, and then the actual value of x, because an integer.
It would, no, you got the last two items reversed. It will print x equals the actual integer value and then a new line.
Oh,
Because the \n is the last thing here, so that means the end of line is the last thing it will print.
thank you.
Sure. Alrighty, so let's go ahead and take a look at this one here. Okay, this one and this one here, they're supposed to be happy faces or different happy faces. One with sunglasses on, the other one without. When I convert this into PDF, you know, that symbol was lost because I didn't have the font installed. Okay. All right. So what we'll do is we're just gonna say this is the last or the rightmost digit of your student ID. So if you look at your 7-digit student ID, this is the rightmost digit, and this is the second last digit of your student ID, which means it's the second last one to the right. Okay. Does everybody know, you know, what to do in the question like this? Okay. All right. So I will just give it a certain test case here. Okay, so that's, well, in fact, we'll just give it the same test case as the first one. Okay, so we're talking about 7 going into x, and we're talking about using 6 going into y. Is that okay? Because, you know, 7 is the last digit, the least significant digit, and then 6 is the second last digit. Okay, so the first thing it's going to do is it will call f with x and y as parameters, and whatever f, x, y returns, it will store into x. Okay, so what do you think would be the what do you think will be the values that we are passing to f in the first invocation?
76.
Okay, it will be, okay, x is 7, right? And then y is what? 6. Okay, very good. And once you get into the function, the first thing we do is to print x equals something, y equals something. Let me just explain which part we're talking about here. So what do you think this particular statement is going to do?
Just say what's inside x and y.
Sorry?
We just state what's inside x and y.
Yep, exactly. So it will print out literally, it will print out x equals and then an integer value, which is the value of parameter x at this point, and then it will print a comma, then it will print y equals to, and then the actual value of y at the time. Okay? All right, that's good. You know, we just got printf explained. Okay, so what do you think this is going to print? It's going to print x equals 7, comma, y equals 6, because those are the exact values of the two parameters. Okay, and then what are we going to do? We will evaluate the expression. Okay, so what is the name of this entire expression? Overall speaking, what is the last operator called? The last operator means, you know, the very last thing that we do with this particular expression. What is that?
Ternary.
It's called a ternary operator. With the ternary operator, what do we do first? We okay, with the ternary operator, we got 3 parts. Okay, we got 3 expressions. Which one do we evaluate first? The first one. Very good. So with the first one, x is greater than or equal to y. Okay, is that true or not? Okay, x is greater than or equal to y is true. So that means the actual value of the ternary operation is what? Is it going to be the first, the second, or the third expression? Second expression, yep. So that means, you know, x plus y is the actual value, right? So that means, effectively we are saying r equals to x plus y, but since x is 7, y is 6, so that means r effectively gets a value of 13. Is there recursion in this particular case? There's no recursion because the first expression of the ternary operator is true, so we only choose to evaluate the second expression. It's the third expression that is recursive, so in this case we don't have to deal with the third one. Okay. And then we have another printf. The next printf is just printing, what is it going to print? Just r equals to, what do you think? 13, very good. And it's going to return r. So we're executing return r here. And what is return r going to do as a statement? It specifies the return value of the function. Go ahead.
It's going to take the value of r back to the main and put it into x.
Yep, exactly. That is exactly what it's going to do. So in main, okay, so back to main, we have x equals to 13 because r has a value of 13 at the time. And then we have a printf right after this. Okay, so the printf right after this is going to print, well, not very exciting. It prints x equals to 13, right? All right, now we have a second call to function f, but this time I reverse r and x. Excuse me, I reverse y and x as variables to the parameters. So this is the second invocation of f. Okay, what is parameter x to f?
13.
It's new. Okay, we're dealing with this statement here. Okay, so the first parameter is local variable y of main being passed to parameter x of f. What is the current value of y of main? It is still 6. We haven't done a single thing about y, so it is actually just 6. Okay, and what about parameter y? What do we use to specify parameter y? We use local variable x of main to specify parameter y of f. And what is local variable x at this point? It's 13. That is correct. Okay. So after this call, we start from the very beginning of function f. The first thing we do is a printf, which means we have to print x equals to 6, y equals to 13. Okay, and then we evaluate the ternary operator. In the ternary operator, x is greater than or equal to y is false. Okay, which means now we have to evaluate the third expression, which is f. Okay, so now we have to start the second evaluation, the second invocation of f. Okay, what are the parameters?
X equals 13, y equals 6.
Yep, that is correct. Okay, because we are using parameter x of the first invocation to parameter. Okay, I just forgot what I said. So let me roll back. We are using parameter y of the first invocation, which is 13, to specify parameter x of the second invocation of f. So that's why x equals to 13. And then we are using parameter x of the first invocation of f, which has a value of 6, to specify parameter y of the second invocation, and that's why it is 6. Okay. It's hard to spell it out, but when it's spelled out, it's like that. Okay. So then it will print again, x equals to 13, y equals to 6, because it has to start from the beginning of the entire program. And then after that, we have the ternary operator. The ternary operator this time will still do the same comparison, but this time x is greater than or equal to y is actually true. So that means the r is going to get the value of the second expression, which is just x plus y, which is 19. Okay. And then it will print r equals to 19, because that's just what the third statement. That's what this statement is going to do. R equals to 19, and then it's going to return 19 as a value. After it returns a value of 19, what is that 19 being used for?
It is added to 1 and then returns the value for the
Exactly. We have to remember to add 1, because that's why we had the second invocation. So when we come back from the second invocation, we have to remember to add 1 to the value, the return value. So now we have r equals to 19 plus 1, which is 20. And then the next statement is going to spell out what R is, which is 20. That's the print statement. And then we return a value of 20. What do we use the return value of the first invocation of f for? Where do we go back to?
To add first x, the
Yep.
local x of main at that point.
Exactly. We are going back to this place here. So this entire invocation of f is substituted by the value of 20. So that becomes x plus equal to 20. But this x refers to local variable x of main, which currently has a value of 13. So we have x plus equal to 20, and that makes x, which is, okay, this is really saying the same thing as x equals to x plus 20, but since x has a value of 13 at this point, basically x now gets a value of 33, and that's it. Well, okay, we have another printf statement here that prints x equals to 33, and that's the end of the trace. Okay, so are there any questions? I think the biggest challenge of this kind of question is how are you going to track, okay, the values of the local variables, the invocations, and what do you do at the end of a function invocation? Where are you returning back to, and what are you doing with the return value? So I haven't really taught you guys how to track that because it is up to you to decide how you want to do it. Yep.
Yeah, it was easy for the first part before we go to the main. And then from the main on, so that we link up from the 10R values, then we go to the main.
Okay, can you name which line in the trace we are talking about here? On this side, can you kind of indicate where you have a question?
Yeah, x is equal to 13.
Here?
Yeah, the bottom one.
You mean this one here?
Yeah, from there,
That's a print statement. This is a printf statement from here.
yeah, that's where I was almost confused.
Okay. Are there any suggestions? Okay, I obviously have the answer, but are there any suggestions from you guys how you can keep track of the execution of a program like this? Write it out, okay? You can number the lines, okay? The first thing you can do is to number the lines, okay? So when you go to a particular subroutine, you can say, okay, when I'm done, I need to go back to line so-and-so, okay? This is the kind of stuff, unfortunately, that should have been covered in cisp300, depending on who's teaching the class. How many people got exposure to how to track program execution like that in 300? Okay. So do you guys feel okay with this or not? Okay? No? Okay, so for those of you who did not get an exposure of how to track variables, parameters, and how to return, okay, this is what I did, in this trace here, but it's not a complete trace. If you want to get a complete trace, the first thing you want to do is to number the lines first, okay, so that you can refer to different lines. It's not really feasible for me to teach the full notation in this class, but let me just kind of go back here and see if I can indicate something. Because I'm trying to use this as an example so I can give you guys a suggestion of how to track the execution of this program. The way I taught cisp300 is to use a table, okay? It's going to take, well, maybe not too bad. Okay, I can do it. Okay, so the way I do it is to use a spreadsheet, and obviously you do not have access to a spreadsheet during the test, but the use of a spreadsheet is nothing more than just use it as a table, as a table, so it's easier to, so I don't have to align anything. So let's see, let's move this one out of the way like this, and we get rid of this one. Don't save. Get rid of this one. Don't save. There we go. All right. So the way that I usually do it is I will first number the lines. that doesn't work. Yeah. Try to find out, how to proceed with this, okay? For those of you who could not track the execution of this program, where did you get lost? That's the trace is on the right hand side, okay? So when do you lose track of, where to proceed or how to proceed? Let me see if I can turn on line numbers. There we go. Because that will help me determine, how to help you keep track of the execution of the program. Yep. Mm-hmm.
Yeah, for after x is equal to 13, then f(x) is equal to 6 and y is equal to 13. That's what.
Okay, on which line? Can you refer to the line number?
Line from starting from line 13.
Line 13, okay. You mean here?
Yeah.
Okay, so your question is, how did we get here?
Yeah.
But you were okay all the way up to here.
Yeah.
Okay, very good. Okay, so this is the output of the first printf. So this particular printf is what is producing x equals 13 as the output. Is that okay?
Mm-hmm.
All right. So that means we need to execute this particular statement as the following statement. Is that okay? Now, in order to figure out what we are actually adding to x, because x plus equal to is a compound assignment operation, which means we have to first evaluate the right-hand side. So that's why we have to call f again. Is that okay?
Oh, yeah.
Okay, so now, when we're calling f in this particular statement, what are we passing to parameter x of y? What are we passing to parameter x of f? We are passing y to parameter x of f. Is that okay? Because x is the first parameter. And then we are passing local variable x to y, to parameter y. Okay, is that part okay?
Yeah.
Okay, so that is why in the trace we end up with 6 for x, because y as a local variable of main got a value of 6, but it never changed. It was never changed. And then parameter y got a value of 13 because it's getting it from local variable x of main, and local variable x of main got changed because of the statement right before the printf. Is that okay?
Yeah.
So that means what you need to do is to have some way to keep track of the values of the local variables. Okay? But remember, local variables and parameters are on a per invocation basis. So every time you have a new invocation, then you have a new set of parameters and local variables to track. And you have to know, which invocations invocation you're dealing with in order to change the right variables. Is that okay?
Yeah, I'm getting it.
Okay. Alrighty. Any other questions about this one? No. Okay, let me go over the other ones first, because I want to go over all of the questions, and then we can come back and I can tell you how I would track the execution of this program. But it's going to be kind of a rush job because that really should have been gone over in 300. So let's deal with question 3 and 4, and then we'll go back and look at how we can track all that stuff. Question number 3 involves the use of pointers, right? So we can see pointers here, and so it's the same nature. Okay, in this case we want to track the values of I and k and so on. In fact, I'm going to use this one as an example of how to track the execution of programs and how you can represent all kinds of stuff like this in an actual program. Okay, so let's go ahead and do it. I'm just gonna bite the bullet and do it here. Okay, so what I would do normally in CI/SP300 is I would just basically write the code again, but with line numbers. The line numbers will come, after this. So int x, and I'm not going to do all the printf here. Okay, so I'm just going to say track. When I say track, it means I need to know the values of px, py here. T equals asterisk px. It automatically changed the cases because it has auto correct turned on, so I need to turn it off. Okay. Px equals py, py equals t. Okay, so that's the inside of the swap subroutine. And I'm going to use the indent feature to indent this whole thing. And then we have main. Okay, so in this case, this is supposed to be the rightmost digit of my student ID. So in this case, the test student ID is 1, 2, 3, 4, 5, 6, 7. So I'm going to use 7 here. K is I plus 3. Track I and K. Swap %I, %I. That is not a typo. That's intentional. Track I K. 0. Okay. Indent. There we go. Alright, so I just entered the entire program. Now it's for the time for the line numbers. There we go. Alright. Alright. Is that okay so far? I just got the entire program retyped, except this time I have line numbers. Okay. We're going to add a new sheet here, and we can open a new window for this particular sheet. There we go. Alright, so the way I usually track this type of a program, back in CI/SP300, is I would start the execution. So in the trace, each horizontal line or each row is representing a slice of time. Each vertical column is representing a variable or a parameter. Okay. In this case, we have main, so we are invoking main. There's no return value that we need to worry about because whoever calls main we cannot see, so we don't really know how the return value is being used. We know it's the exit code of the entire program at this point, but that's not that important. What we do need to know is I and k are two local variables of main. So you need one column for I and one column for k. Oh, I forgot one more thing. I forgot a line number. Okay, so the line number column is just a indication of when we execute which line, which variable got changed to what value. Okay, so line 13 doesn't really do anything. All it does is to declare that we need variables I and k in main, so it doesn't really do anything. The first line that actually does something to the variables is going to be line 14. I gets a value of 7. K has an unknown value because it is not initialized. On line 15, I'm not going to repeat things that are already there and not changed, but in this case we know that k is getting a new value because it is getting 7 plus 3 which is 10. Are there any questions about this trace at this point? Is everybody kind of understanding that each slice of time is just a row, okay? All right, and then we get on to line 16. So line 16 doesn't really have much to do. What I also do in my cisp360 is I have one column called comments, okay? All it does is to keep track of what is the output of the program. So in this case, the output of the program is I is 7 and k is 10, because those are the actual values of I and k at that point. And then we get to line 17. Now line 17 is special because it is a subroutine call, which means we need to allocate additional columns. Every time you invoke a subroutine, you have to have new columns to represent the parameters, where you're supposed to go back to, and also the local variables. Okay, so all of those things, everything that is on a per invocation basis, they have to have columns allocated when the subroutine is called. So in this case, on line 17, when we call swap, okay, we will have to do all kinds of stuff like that. The first thing in this case is easy because we just have to return to a certain line. Where am I supposed to go back to when swap is done?
Line 17.
No, if I go back to line 17, I'll be calling swap again.
Oh, it's 18.
Yep, so the return line number is where am I supposed to go to continue execution after the subroutine call. In this case, it is line 18. And then I will have to allocate columns for the parameters as well as the local variables. I usually start with parameters first. What are the names of the parameters? Come on, you guys can see on line 1, okay, it spells out the names of the parameters. We got px and py. Those are the names of the parameters. So we have px as a parameter, py as a parameter, and we also have a local variable. What is the name of the local variable of swap? T, okay, very good, okay. Okay, now, in cisp360, we don't have addresses, but we can still know, we will still be able to do that. What is a pointer? What is the job of a pointer? It stores n, it starts with an A. Address, very good. And what is the purpose of an address? So that we can follow the address and get back to the original item. Is that okay? All right. So px is an address. Now, what is the address of whose address is supposed to be stored in px? On line 17, what is the first argument used in the call?
The address of I.
The address of I, very good. Okay, so the address of I is the value of px. So the question now is, how are we going to represent this? What about, we just refer to the column number. Okay, and local variable I of main is using which column in the spreadsheet?
Wait a second. Where did I equal px?
That's the first parameter, that's the first argument, and this is the first parameter. They are all matched by position.
Okay.
So ampersand I is the argument to pass to px. Is that okay? Yeah. All right. So in this case, since we're not dealing with actual addresses like we can in GDB, in the spreadsheet it's easier. Okay. All I'm gonna say is to say C column. Which column? Which column is local variable I of main? Column C. Very good. Okay. And py is the same thing. C column D. Okay. And t as a local variable starts with what value? It's a local variable that is not initialized. What is the value of such a thing? Unknown. There's a value, but we have no idea what it is, so we just put a question mark here. Okay. Now we continue execution in swap. Okay. Line 3 doesn't do a single thing. Line 4 is blank. Yep.
Would py be column C also because you said?
Oh, you're correct. Okay, I forgot that it was intentionally the same. Okay, very good. Thank you. I forgot about that. Then we can continue execution on line 5. Line 5 doesn't do a single thing. All it wants to do is to say, oh, px is, oh, what is at px? Okay, asterisk px means follow the instruction to go to that column and tell me what is the value of that column. What do you think asterisk px is going to be as a value? What is on column C at this point? 7. Very good. Okay, so that is 7. And what about py, asterisk py? It's also 7 because they are both referring to the same column, so they are both 7. Yep.
Was track covered in the pointer material?
No, it's just printf.
Oh,
Print up an object code.
is how, did we learn that somewhere and I just missed it?
Printf or track?
Track.
No.
Track is printf.
Yes. Fine.
Okay.
It's a short one.
I just wanted to make this a little bit easier. Okay, it's just printing, okay? That's just printing the values of whatever the expressions are. Okay, so let's move on to line 6. Line 6 is kind of the first thing that is a little bit hard to do, okay? Up to this point, nothing is really hard. Okay, what does line 6 do? Line 6, is an assignment operation, which means we have to evaluate the right-hand side first. What do you think is the value of the right-hand side, asterisk px? It says follow px, right? And px tells me to go where? To column C, which has a value of 7. Okay, so 7 is the value of the right-hand side, and what are we doing about the value 7?
Assigning it the value 7.
We use 7 to update
the
t.
address.
Very good. Okay, so t is now updated to a value of 7. Okay, so this one is not too bad. What about line 7? What is it going to do? First thing is the right-hand side. Asterisk py. Yep, go ahead.
It's taking the value at the address of I now, and then
Yep, it's
assigning
going.
value of address of I, which brings 2 questions to mind.
Yeah. Now the question is, how do we represent it? Okay, because py is an address. It says, okay, go see column C. Column C is this guy. It still has a value of 7, right? So that means the right-hand side of the assignment operation is 7. What are we doing with that 7? Store it to the column that is pointed to by px. Px is saying, okay, go to column C. So that means even though we are not really changing it, this is what is happening. It is actually, quote unquote, overwriting column C with a value of 7. Now you might say, hey, but it already had the value of 7. Why do we bother to indicate this is overwriting the value 7 with a 7? Because that actually happens. Okay, the memory write operation actually occurred. It's just that it's overwriting that location with exactly the same value as what it already had. But it is still important to indicate that this is, it's getting an update. It's just that the updated value is the same as what it had. Are there any questions about line 7 or what line 7 does? Yep.
So functionally, is it bothering to go all the way to that address and swap what it was there, or is it just saying value 7 because the earlier part checked?
Well, functionally speaking, if you don't put anything here, that means there's no attempt to change anything. But if you put a 7 here, even though it already had a value of 7, you're indicating there is an assignment operation. It's just that we are overwriting that location with a value that was already there. But that's important, okay? In a trace like this, this is actually important. And then we get to line 8. What is line 8 going to do? The right-hand side is 7, is t. What is t? T has a value of 7, and what are we doing with that value of 7? Follow py and change that column to the value of 7. But py tells me to go to column C, so that means I go here, and I still have to indicate there's an update. Is that okay? Even if it had the value of 7 and the new value is also 7, you still have to indicate in the column. But at least that's the way I taught that class. But in this class, I'm not, this is optional material. So on line 9, I'm just tracking it. So px equals 7, py equals 7. Well, whatever is pointed to by px is 7. Whatever pointed to by py is also 7. After line 9, okay, in the way that I represent subroutine, dealing with subroutine, In this case, I have to go to the rightmost return line number, which turns out to be column E in this case. It tells me to continue execution on line 18. So I first write down the line 18 here. But there's one thing that is also important. Everything that is specific to this invocation is also going to be gone because I'm returning from a subroutine. Just because these 4 items are allocated on the fly when we invoke a subroutine also means when the subroutine is all done, everything that we allocated for that invocation will be gone. Okay, they will be deallocated. So the way I taught CISP300, this is what I usually do. I will copy and paste these cells and then go to format, font, okay, where is it? Format cell, number, no, it's not one of these. Because I usually use a cross out for these things, and maybe it's under cell, font, there we go. Font effect, use a strike through. So that's the way I usually do it, okay? Because since you guys want to know how I would track something like this is how I would track it, which also means column E is once again available. So the next invocation of any subroutine will reuse column E because column E is now deallocated. Yep.
Because we're using pointers, is swap actually altering the contents of I and K, or is it just taking the values from those?
Say again here?
So because we're using pointers, is swap basically a by reference in terms of altering contents of I and K, or is it just feeding the values of the location?
Okay, let's talk about the operation of a particular line. Which one do you want to use?
So one.
Line.
Just line 1 void swap and feeding the parameters with pointer.
Okay, so when you pass the parameter, which is on row 6 of the spreadsheet, this is what happens when you call a subroutine. You allocate the columns for the appropriate parameters. So in this case, we have parameter px, we have parameter py. But at the same time, you use the arguments, which is in the invocation itself, to fill in the blanks and say, okay, we are using the address of I to specify px as a parameter. We're using the address of I also to specify the parameter py. So that's why in the trace, px is saying, okay, go see column C because it is an address, and an address is just telling you how to get to a place, right? And py is the same way, but they both tell you to go to the same place because they're both ampersand I. Okay?
No, my question was just because we're using pointers and address operators in the parameters,
Yeah.
will swap all the values of I and K during its frame, or is it just taking the values from whatever address is being used?
It's just taking the values at those addresses. In other words, swap as a subroutine has no awareness of local variables I, K in main. It doesn't even know whose variable they are. It just knows the addresses that it's supposed to mess around with. Yep. Okay. All right. So back to line 18. Line 18 doesn't do a whole lot. It just wants to track I and K. All right. Well, tell me what is I at this point. I is still 7 and K is still 10 because we haven't done a single thing about those two variables. Yep.
On the pointers, don't in C++ it acts as pointers already, like when you're passing by a reference, it's pointing to.
But this is not passing by reference. This is actually passing the address.
Oh, the pointer is passing the address.
Oh.
Because we are using the ampersand here and we're using the asterisk here. So we are actually dealing with addresses and not passing by reference, even though the mechanism is about the same.
Okay, and I'll be able to look at that discrepancy if I read the pointer material. Is that correct? Okay.
Yep, go ahead.
So, were you to update the address of I in the void swap?
The address of I?
Yeah, so would it have
Can you refer to a row number in the trace or line number in the...
7? If it were updated rather than 7, I, if you'd updated it to 8 or 9, would it have updated it in the main subroutine?
Yes, it would have.
Okay.
Yep, you mean here, actually. This is the line that you're
Yeah,
referring
sorry.
the row that you're referring to.
Yes,
Yep.
right.
Yeah, it didn't do a single thing in this case because I was using the same address as px and py, so there it's referring to the same values.
So basically, when using address and pointers, you're leaving the variables behind and you're messing with what's actually stored in memory, like the address of what's
That is
stored.
correct. As far as swap is concerned, it only knows which column it's dealing with, but it doesn't even know who owns that column, which invocation or the name of the local variable. All it knows is, I know where it is. It's kind of like, just knowing the street number and also the street of a particular address, but you don't know the name of the business or the owner or whoever is living in the house. It's just saying, okay, go to this particular location and drop off, a letter. Okay, that's fine. But you have no awareness of, who owns it, who's living there, what is the business, and so on. Yep. Is that okay? So I know this is kind of a rush job because this is the kind of stuff that I would have covered in CI SP300. Yep.
If you wouldn't just, for all intents and purposes, if you wouldn't have used pointers in the parameter pass, and instead of a star you had an ampersand,
Okay.
that would be
Then I would
by
just-
reference,
Yeah, it would be a by reference,
and it
and
would
then I'll
still
just
all work.
it will still work about the same way.
Okay.
Yes. Okay.
Would there be a case ever where it would not work the same way?
Well, when we deal with arrays, it would be a little bit different.
Okay.
Any other? Yep. Go ahead.
I think I confused myself or not. So, just removing the fact that it's feeding the address of I and I, let's just say, for sake of argument, it's feeding address of I and address of K.
Okay.
In those cases, would it be altering the actual contents of I and K?
Yes,
maybe?
it would.
Okay.
Okay, so let's go ahead and just change it. Okay, so I'm going to change this to the address of K here. And the reason I skipped J is because J looks really kind of like I. In most fonts, those two look very much alike, and that's why I did not use K. Did not use J. So that means, when we get to line 17 in the trace, which is on this row here, we have to say, okay, this is not referring to column C anymore. It will be referring to column D. Yep, that's right. Okay, so when we get to line 7, okay, when we get to line 5, PY is no longer pointing to a cell that has a value of 7. PY points to a cell that has a value of 10. Yep. And by the time we get to line 6, line 6 doesn't really change much because PX is still saying is referring to the same column, which has a value of 7, so T still has a value of 7. But the next line is going to be different because on line 7 in the code, which is row 9 in the trace, what is the right hand side? The right hand side says follow PY. PY is saying go see column D. Column D has a value of 10. So that means the right hand side of the assignment has a value of 10. What are we doing with the value of 10? We want to store it to whatever PX points to. PX points to column C, so that means column C this time is actually going to be changed to 10.
I just want to make sure I was understanding the mechanism why. With the
Mhm.
second call to that, and my blank, never mind, I forgot what it was.
Okay, so if I change the program to use the address of I and the address of K, then this would have been the outcome of the program.
Okay, never mind, now I've got it. So
Yes, go ahead.
That is acting as an active pointer there. Is an active pointer because it's declared as a pointer value in the definition of swap, or is it
Yes.
because it is, okay, so it's the definition, not the fact there's the,
Well, they have to match.
okay.
So the argument that you use on line 17 has to match the type of the parameter. In this case, the parameter has a type of address of an integer, so you cannot pass an integer to it. There's no automatic conversion from a variable to the address of the variable.
Oh no, I don't know the problem, I'm sorry, in the body of swap itself,
Mm-hmm.
because you have the dereference operators in front of PX and PY.
Yes, dereference can only be used when you have an address. Because dereferencing is kind of the same thing as saying follow the instruction, right? Go to the address. So that's basic. So you have to start with an address.
I guess, right, with phrase, if I had PX and I had any operation, but I did not include the dereference operator, would that do anything, or is it effectively?
Well, that is an interesting question. So you're basically saying, what if Okay, for instance, on line 6, what if you are to do something like that? That's a good question. What do you think? Okay, so think from the perspective of the compiler. Okay, the compiler says this is an assignment operation. It wants both sides to have the same type. Okay, the type of the right hand side is, what is px?
Int.
No, px is not an int. It's related to an int, but it's not an int.
Pointing
It's
to
an address to an int. Okay, what is t?
local variable.
Int.
T is an int. T is the type of t is an int. So you have an int on one side, you have the address of int on the other side. Coercion does not work in this case. Okay, coercion cannot go across the address of versus dereferencing. It does not do that automatically, which means in this case, this would actually be a compile time error. The compiler would indicate and say the two types are different, and there's no way to reconcile the types automatically. So there are many ways to reconcile the types, okay? But which one is the correct way depends on the context. So in this case, the only way that is correct is to do it like this. So that's a very good question, okay? So one thing you guys can do, well, we are kind of running out of time, so we have one more question to go. Let me just kind of take a quick peek at that question. Question number 4 is, oh, it's kind of fun. Okay, question number 4 is kind of fun. This one you can actually track it using GDB. All of these programs actually compile, okay? They all compile. You can track every single one using GDB. So you might want to apply what you just learned a little bit ago, using the trace approach to figure out what is happening with this particular program. And I can point out, what is the tricky part here. The tricky part is we have a PR as a parameter, but it's an address of an integer. So whenever you do something with it, such as here, you have to think about, okay, but what are we actually doing? Are we changing the parameter itself, or are we changing what the parameter is pointing to? And what the hell is it pointing at? Okay, well, it depends on how we pass to that parameter. What are we passing to that parameter? So you might want to use this one as an exercise. Okay, I can always record the actual answer, at home, but you guys can work on this one. Really just work it out on a sheet of paper, especially for those of you who are kind of new to how to trace the execution of a program. Okay. As one last remark, I know we are out of time already. What is the point of being able to trace the execution of a program when you can have a computer and GDB to run the program? What is the point of tracing it?
Debuggers can't catch logic errors.
Okay, that's one point. That's a good point. What does it say if someone cannot trace a program? I'm not talking about the technique. I'm just talking about not being able to follow a program and know what it's supposed to do. Yep.
You can't trace a program before you can't follow the logic of the program in the first place.
Exactly. Okay. So even though in practice we have computers to execute these programs, but as developers, as programmers, we always should know exactly what the program is supposed to do, for simple cases. Okay. So that's why I really personally emphasize the concept of tracing a program by hand, but it obviously is not agreed upon. Alrighty, so I'll see you guys on Wednesday.